A turbocharged engine is a clever bit of engineering. It uses the engine's own exhaust gases, which would normally just be wasted, to spin a turbine. This turbine is connected to a compressor, which then forces more air into the engine's cylinders. More air means you can burn more fuel, and burning more fuel creates a bigger bang. This results in more power from a smaller engine. It is a brilliant way to improve both performance and efficiency. However, this process of forcing extra air into an engine creates pressure, which we call boost. Uncontrolled, this boost pressure can quickly become a problem for the engine. This is where special valves come into play. A turbocharger can spin incredibly fast, sometimes over 200,000 revolutions per minute. If you let it spin freely, the boost pressure would climb higher and higher until the engine itself was damaged. The pressure could become so great that it could break pistons, bend connecting rods, or blow head gaskets. To prevent this catastrophic failure, engineers need a way to manage and limit this pressure. They need precise control systems to ensure the engine always operates within its safe limits, delivering power reliably without destroying itself in the process. So we have two primary devices that help manage this pressure, the wastegate and the blow-off valve. Many people, especially those new to the world of cars, often get these two components confused. They both manage pressure, and they both make distinctive sounds, but they do completely different jobs at different times. The wastegate's job is to control how fast the turbo itself spins. The blow-off valve's job is to release pressure in the intake pipe when you suddenly close the throttle. Understanding the difference between them is key to understanding how a modern turbocharged petrol engine works so effectively. Think of it like this. The turbocharger is a powerful force that needs to be carefully tamed. The wastegate acts as the reins controlling the source of the power. The blow-off valve, on the other hand, acts as a safety release, dealing with a sudden buildup of pressure that occurs during a specific driving action. Both are essential guardians of your engine's health, working in harmony to deliver that exhilarating turbocharged performance we all love. Without them, the turbo would be an uncontrollable and destructive beast rather than a useful tool for making power. The wastegate is the turbo's primary boost controller. Its name tells you exactly what it does. It is a gate that lets some exhaust gas go to waste. Remember, exhaust gas is what spins the turbine. The more exhaust that hits the turbine blades, the faster it spins and the more boost it creates. The wastegate is a valve that creates a bypass route for this exhaust gas. It allows a certain amount of exhaust to skip the turbine entirely and go straight into the exhaust pipe. This is how we control the turbo's speed. Let's imagine you are accelerating hard in your car. As the engine revs increase, more and more exhaust gas flows towards the turbo. The turbo starts spinning faster, and the boost pressure climbs. Your engine's computer is monitoring this pressure. Once the boost reaches its target level, say 15 psi, the computer sends a signal to open the wastegate. This diverts some of the exhaust gas away from the turbine. With less gas hitting its blades, the turbine's speed stabilizes, and the boost pressure is held steady at that target of 15 psi, preventing it from climbing any higher and damaging the engine. There are two main types of wastegates, internal and external. An internal wastegate is built directly into the turbine housing of the turbocharger itself. This is the most common and cost-effective type, found on most factory turbocharged cars. An external wastegate is a separate, larger component that is plumbed into the exhaust manifold before the turbo. These are typically found on high-performance and motorsport applications, where more precise and greater exhaust flow control is needed to manage very high levels of boost. Both types, however, perform the exact same fundamental job. So the wastegate is active whenever you are accelerating and the engine is creating boost. It is constantly making small adjustments, opening and closing to keep the turbo spinning at just the right speed to deliver the amount of boost the engine is asking for. When you hear people talking about turning up the boost on a tuned car, what they are often doing is adjusting the settings that control when and how much the wastegate opens. It's the master switch for controlling the turbo's power output while your foot is on the accelerator. Now let's talk about the blow-off valve, which is sometimes called a diverter valve or dump valve. This component has a completely different job. It isn't concerned with how much boost the turbo is making. It is concerned with what happens to that boost when you suddenly lift your foot off the accelerator pedal. Imagine you are accelerating at full throttle. The turbo is spinning fast, and the entire intake system, from the turbo's compressor to the engine's throttle body, is filled with highly pressurized air. It's a column of fast-moving, high-pressure air heading for the engine. What happens when you abruptly close the throttle plate by taking your foot off the gas pedal? That pressurized air suddenly has nowhere to go. It slams into the back of the closed throttle plate, creating a pressure wave that travels backwards towards the turbocharger. This phenomenon is known as compressor surge. This reverse pressure wave can be very damaging. It pushes back against the compressor wheel, trying to stall it or even spin it backwards. This places a huge amount of stress on the turbo's bearings and can significantly shorten its lifespan. This is where the blow-off valve saves the day. It is a pressure relief valve located on the intake piping between the turbo compressor and the throttle body. It is designed to sense two things: high boost pressure in the intake pipe and a high vacuum in the intake manifold, which happens when the throttle closes. When both of these conditions are met, the blow-off valve opens instantly. It vents all that trapped boost pressure, either back into the intake system before the turbo, a diverter valve, or out to the atmosphere, which creates that famous psh sound many enthusiasts love. By releasing this pressure, the blow-off valve prevents compressor surge, protecting the turbo from harmful stress. So, the blow-off valve only operates for a split second, specifically at the moment you lift off the throttle after being on boost. It has no role to play while you are accelerating. Its sole purpose is to act as a pressure release safety net during gear changes or when you suddenly decelerate, ensuring the turbo remains healthy and ready to spool up again when you get back on the gas. So, to compare them directly, the wastegate controls boost pressure while you are accelerating, and the blow-off valve releases boost pressure when you stop accelerating. The wastegate manages the source of the pressure, the turbo's speed, by controlling exhaust gas. The blow-off valve manages the result of that pressure by venting the intake air. One is active under power, the other is active when you lift off the power. You can see they are not in competition with each other. They are teammates, each with a critical and distinct role in the system. So, which one is better? This is not the right question to ask. For a typical turbocharged petrol engine, you absolutely need both. You need the wastegate to prevent the turbo from overspeeding and destroying the engine with excessive boost. You also need the blow-off valve to prevent compressor surge from destroying the turbocharger when you lift the throttle. They are not interchangeable. Removing the wastegate would lead to uncontrolled boost and engine failure. Removing the blow-off valve would lead to damaging the turbocharger over time. Both are essential for performance and longevity. But why do diesel engines usually only have a wastegate? The answer lies in how they control engine speed. A petrol engine has a throttle plate that opens and closes to let air in. A diesel engine does not. It has no throttle plate. The intake path is always wide open. Engine speed is controlled purely by how much fuel is injected. Because there is no throttle plate to slam shut, there is no risk of the pressure surge that a blow-off valve is designed to prevent. The pressurized air always has a path into the engine, so a blow-off valve is simply not necessary. In summary, the wastegate and blow-off valve are two vital but very different parts of a turbocharged system. The wastegate is the boost regulator, working hard while the engine is under load to keep the turbo in check. The blow-off valve is the turbo's protector, working in the split-second moments when you lift off the throttle. Petrol engines need both for a happy and healthy life. Diesel engines, thanks to their lack of a throttle body, can get by with just a wastegate. Understanding their individual jobs is a fundamental step in appreciating the the brilliant engineering behind turbocharged engines.